Here's our second video in Unit 1 of College Algebra. By the end of this video presentation, we should be able to evaluate expressions containing exponents by applying the laws of exponents. I want to send a shout out to Coleman Foster today because he is taking both of my math classes. For some reason, when I transfer my PowerPoint presentation over to this app on my iPad, math type doesn't show up, so I'm having to rewrite these things for you today. But they should already be on your note page. So exponents are just another way for us to represent repeated multiplication. So 2 to the third power is actually 2 times 2 times 2, which is equal to 8. Anything raised to the power of 1 is equal to that thing, whether it be a variable or a number. So 10 to the first is equal to 10. If I had x to the first, it would be equal to x. And the last one here on this slide, a to the 0, anything to the power of 0 is equal to 1, letter or number. On this particular slide, we've got some parentheses involved that kind of change up things a little bit. And we need to be careful when we're having to use parentheses and negatives and raising the exponents in the calculator as well. So negative 2 to the fourth is a negative 2 written 4 times. So we're going to multiply negative 2 4 times. So negative 2, negative 2, negative 2, negative 2. And when we multiply those together, we get a positive 16. The second example, a negative 2 to the fourth power, doesn't have the parentheses. And we would write it in this way, the negative, and then we would have 4 2's, not negative 2's. And when we work this problem out, this inside of the parentheses gives us a positive 16, but the negative on the outside makes our entire answer a negative 16. And then last down here we have x to the negative n. Anytime we see a negative exponent, we want to try to get rid of it because we do not write our answers with negative exponents, only with positive. And when you have negative exponents, you can kind of think of a reciprocal. So the reciprocal of x to the negative n would be 1 over x to the positive n. And changing that negative exponent's location from the numerator to the denominator causes it to be positive. So going off the example we just completed, 2 to the negative 3, since we have a negative exponent, we would think of this as 1 over 2 to the positive 3, which is 1 over 8. Again, the same thing with the last example on this slide. 1/5 to the negative 2, we can think of as 1 over 1/5 to the positive 2. If I do 1/5 squared, I get 1 over 25, so I have 1 over 25, which is 1 divided by 1 over 25. And if I were to work all that out and show all my work, that would be 1 divided by 1 over 25. And so when I divide fractions, I have to flip the second and multiply. So I have 1 times 25 over 1, which is equal to 25. Alright, now getting into the laws of exponents. This first law says if I have two things I'm multiplying together that both have exponents and they have the same base, both of these have the base of x. Well, if I were to write all those out, I would have 5 x's total, 2 from here and 3 from here. And so I would write that as x to the 5th. So the law states that if I have the same base, I can add the exponents. So that's what we need to remember. When multiplying exponents, you're really going to add them. So based on the law we just discussed, I have the same base of negative n, and these parentheses means I'm multiplying these two things together. So I can write this as negative n to the negative 1 plus negative 7, which is equal to negative n raised to the negative 8 power. But remember, I don't write answers with negative exponents, so this is really 1 over negative n to the positive 8 power. And since this 8 is positive, and I mean not positive, since this 8 is even and not odd, I can write this as 1 over n to the 8th. It causes that negative 1 to become a positive 1. The second law of exponents happens when we have a power raised to a power. And so what this power on the outside of the parentheses tells us is that we need to write the inside, x squared, 3 times. And then applying the first rule, I know that that's x equals x to the 2 plus 2 plus 2, which is x to the 6th. And so what the second rule says is if I have a power raised to a power, I can multiply those two things together to get my final answer, as you see down here in the variable example. So if I have a power to a power, that means I need to multiply. So from that example, we have y to the negative 1 raised to the negative 2. Since I have power to a power, I can apply that rule that says I can multiply. So this is really y to the negative 1 times negative 2, and that would give me y to the positive 2. This next law of exponents is kind of like distributing. If I have a term raised to a power, I have to apply that power to both of the things inside, or to all things inside, whatever they may be. And so if I have this n on the outside, I have to give it to both the a and the b, and that's how I get a to the n and b to the n. So this is kind of like distributing. So I'm going to put distribute in quotations because technically it's not the distributive property, but it's similar. So in this example, I'm going to have to give the negative 2 to the a and to the x. And so I get a to the negative 2 and x to the negative 2. But I know that I don't want to write things with negative exponents. So this is actually 1 over a squared x squared. The next law concerns divisions of exponents. So in this particular example, I have x to the 5th over x squared. So x to the 5th means I have 5 x's in the numerator. X squared means I have 2 x's in the denominator. Now, anytime I have something divided by the same something, I know that that's equal to 1. This is why I can cross these two things out, with 3 x's left in the numerator that I write as x to the 3rd. So what this rule does, it says if I have the same base on the numerator as I do in the denominator, then I can subtract those two exponents. So division of exponents means we need to subtract. So for this example, because we have the same base of x in the numerator and the denominator, I'm going to subtract the two exponents. So this is actually equal to x raised to the negative 2 minus a negative 5. Oh, bad 5 there for you. And so this is actually x to the positive 3 power. The last couple of laws we're going to discuss deal with fractions raised to exponents. So in the first one over here on the left-hand side, I have a fraction raised to the power of 5. All I have to do is apply that 5 to both the numerator and the denominator. And that's what this example gives you too. Over here on the right-hand side, we have a fraction raised to a negative exponent. To apply that, if I give this negative n to both the a and the b, I'm going to have a negative exponent in the numerator and denominator. So to take care of that, I just flip it around, and we're done with that part. So when I have a fraction raised to a negative exponent, I need to think again reciprocal. So for the top example, I need to apply this 2 to both the 5 and the 2 down here. So this would be 5 squared over 2 squared, which is 25 over 4. Down here at the bottom, I have a negative exponent. So to take care of that, I'm going to give the reciprocal of the fraction inside, and change that -2 to a +2. And then apply the 2 to the numerator and the denominator of the fraction. And so that gives me 4 over 25. On the last couple of slides, we're going to put all these laws together. For this first slide here at the end, I'm going to apply this 2 on the outside of these parentheses to both of the things inside the parentheses. So the top is going to stay the same for now, but the denominator is going to change. So if I apply this 2 to x to the third, using one of my laws, I can multiply those. So that would be x to the 6th. And then since the y has an exponent of only 1, 1 times 2 would give me 2. Now next I notice I've got these two that go together and these two that go together. And they're division, and division in exponents means I can subtract. So what I can do is say, okay, I know that 5 minus 6 is -1, so I'll have x to the -1. And then I have -2 minus 2, which is -4, so I have y to the -4. But I can't write my final answer with negative exponents. So to take care of those, I'm just going to move them to the denominator, which just means I'm going to give the reciprocal of this answer, x to the first, which I don't have to write the 1, and y to the +4. The first thing I've got to do in this case is apply this -2 on the outside of the parentheses to both the numerator and the denominator. So just rewriting it, it's going to look like this: x to the -3rd raised to the -2 over 3y to the -1 raised to the -2. Now I've got to apply the -2 mathematically to the -3, and I know that a power to a power means I multiply. So I'm going to get x to the 6th. In the denominator, I've got to apply this -2 to both the -1, and I've also got to give it to this 3. So I've got 3 raised to the -2 power, and then I've got y to the -1 raised to the -2. And now I know that, for now, the numerator will stay the same. 3 to the -2 is actually 1 over 9. And I know that -1 times -2 is a +2, so I have y squared. Now this is super messy. We don't ever want to leave a fraction in the bottom of a fraction. Okay, so remember, this is really, coming over here to the side, 1 divided by 1 over 9, which is really 1 times 9 over 1, which I know is 9. So I'm going to get a final answer of 9x to the 6th over y squared. And that concludes the second video in the first chapter.